population of pythons in the Everglades has dramatically dropped.
The tracker went silent just after midnight. By sunrise, biologists are kneeling over a 13-foot apex Burmese python in the Florida Everglades.
Predator becomes prey in the Florida Everglades as hundreds of hunters descend on the Sunshine State.
And something is wrong before they even see the wound. There is no muscle tension. A living snake, even a sleeping one, pushes back against your palm. This one does not. The neck is shredded clean through the spine. The skull is gone, not torn off, taken, and the pine needles hiding the body were not scattered by wind. They were raked into a pile by something that wanted this python hidden. Decapitated invader. For over a decade, USGS researchers have built their entire Everglades conservation strategy around one assumption. Adult Burmese pythons in this swamp have no natural predators. They are too large, too powerful, too dangerous for anything native to Florida to hunt. Whatever did this to Loki didn't just break that assumption, it demolished it before breakfast. Every morning at the United States Geological Survey field station, the same ritual plays out. Researchers log in, pull up the tracking map, and watch the dots pulse. Each dot is a tagged Burmese python somewhere out in the sawgrass, broadcasting its position every few hours. Most days, the map is quiet and predictable. The pythons are eating everything in the Everglades and pushing into the neighborhoods on the edges of it. But on the monitors, they look like nothing more than slow orange lights drifting across a grid. That morning, Loki's dot had not moved since the previous evening. A stationary signal is not automatically alarming. Pythons rest. They hide for days at a time. But something about the location felt wrong to Sarah. The coordinates put him in open ground, exposed, not sheltered. She loaded into the airboat before the rest of the team had finished their coffee. When she pushed through the brush to the exact location, the GPS unit in her hand read 0 distance. He was right there, and there was nothing to see but that loose mound of pine needles. The first thing the biologist on scene felt was that absence of muscle tension. A living python, even a resting one, has a specific resistance, a coiled readiness you can feel through the skin. This snake had none of it. The body lay limp in the dirt, and where the head should have been, there was nothing. The neck had been shredded through the spine, and the skull was gone entirely. The reaction from the team was immediate. Something had killed this snake. It's something deliberate. Here's what you need to understand. This was not a scavenging wound. This was a targeted, deliberate strike to the single most vulnerable point on the body of a constricting snake. Sever the spine directly behind the skull, and the entire muscular system collapses instantly. Whatever killed Loki knew exactly where to hit, and the more Sarah studied the scene, the stranger it got. The pine needle coverage was not random. That behavior is specific. Certain predators conceal their kills deliberately, either to return later or to remove visual evidence of a hunt from their territory. This was not chaotic, it was organized. The team set up trail cameras on every tree within 100 yards and settled in to wait. It came back 4 hours later, and it was not an alligator. It was not a Florida panther. It was a bobcat. A wild cat weighing roughly 25 pounds, barely a fifth of the snake it had just killed, walking up to Loki's remains with complete, unhurried confidence, as if it owned the entire swamp. Small assassin. Stay with me on this, because the size mismatch is the part that should not be possible. The bobcat is one of the most widely distributed wildcats in North America, but in Florida, it tends to disappear into the background, roughly twice the size of a domestic cat. Tufted ears, spotted coat, bobbed tail. They move through dense vegetation like smoke. You can be standing 5 feet from one and never know it. For thousands of years, the Florida bobcat had a stable territory in the Everglades. Marsh rabbits, cotton rats, white-tailed deer fawns, birds. A finely tuned predator locked into the rhythms of a specific ecosystem. Then the pythons arrived and systematically ate everything the bobcat depended on. Rabbit populations in the southern Everglades collapsed by over 90%. Raccoons dropped 99%. Foxes virtually disappeared. The food web that had supported the bobcat for millennia was consumed from the bottom up by something the local wildlife had never encountered. Researchers assumed the cats were retreating, dying out. They were not retreating, they were watching. Bobcats are observational hunters. They study movement patterns. they identify weaknesses. And the Burmese python, for all its biological power, has one critical structural flaw that a patient, intelligent predator would eventually find. The back of the neck, directly behind the skull over the cervical spine, is exposed and thin relative to the rest of the animal's body. A targeted strike there, before the snake can coil and respond, is lethal within seconds. Here's what the trail camera showed. The bobcat studied Loki for over an hour before it moved. The python was stretched out, distracted, partially exposed in the afternoon sun. The cat circled at a distance without making a sound. It closed in stages, never triggering the python's lateral pressure detection. And then, in a motion the camera barely resolved clearly, the bobcat dropped its full weight onto the back of Loki's neck, drove its teeth through the spine, and stepped back. It was over in seconds, not a struggle, an execution. And here's where it gets worse for the pythons. This was not an isolated event. Once the USGS team knew what to look for, they started finding evidence of the exact same behavior at multiple locations across the southern Everglades. Multiple cats, multiple kill sites, multiple instances of concealment. A second camera at Big Cypress National Preserve then captured something even more remarkable. A different bobcat, not Loki's killer, had found a python nesting site and was working through it with methodical precision. It did not simply eat the eggs. It processed the entire clutch one by one, biting each egg, licking the contents, then moving to the next. When it had finished, it covered the destroyed nest with dirt and debris, the same concealment behavior documented at Loki's kill site. Think about what that means. The cat appeared to understand that the eggs were the source of the problem. Not just a food source, but a threat multiplier worth eliminating completely. This behavior had never been documented in bobcats before, anywhere. They were not just surviving the invasion, they were actively suppressing it. And the behavior is spreading. Researchers have now documented this hunting pattern across multiple individuals in multiple territories. Younger cats are exhibiting it. Cats in areas where the behavior was not previously recorded are now showing it. Scientists believe they are watching a form of rapid behavioral transmission, knowledge moving through a population laterally, faster than any standard evolutionary model would predict. This is the kind of ecological response that usually unfolds across generations. It is happening in years. There is a risk calculation happening inside every one of these cats, and it is extraordinary to consider. A 30-pound bobcat attacking a 13-foot python that can generate enough constriction force to stop a human heart is not acting on instinct alone. Instinct would tell the cat to flee. What is happening instead is learned, deliberate, and precise. Identify the moment the snake is extended and uncoiled. Strike the cervical spine before it can respond. Step back immediately. Miss that window, and the python coils. If the python coils, the bobcat dies. There is no margin for error, and they are winning. Pause here. Because what you are watching in the trail camera footage from Loki's kill site is something the headlines have not caught up to yet. A documented ecological turning point inside the biggest invasive species disaster in American history. If this is the first time you're hearing this, hit subscribe right now and turn on notifications. This channel is where the real Everglades science lives, not the recycled wire service summaries, not the Shark Week dramatizations, but the actual field data coming out of USGS and the people working the swamp at 3 in the morning. The bobcat is only the first thing they found. What Sarah Carver's team is watching happen inside the pythons themselves is worse. Because there is a reason the cats matter this much. And it has nothing to do with the cats. It has to do with what the snakes are becoming. Everglades disaster. Here's the short version, because the origin story is not the point. Burmese pythons arrived in Florida through the exotic pet trade in the 1970s and 1980s. Owners released them when the snakes outgrew their living rooms. Then Hurricane Andrew in 1992 destroyed a major reptile breeding facility on the northern edge of the Everglades, releasing hundreds, possibly thousands of animals into the swamp in a single night. That was the moment the invasion crossed from containable to catastrophic. Within 2 decades, 99% of the raccoons were gone from large sections of the southern Everglades. Marsh rabbits, opossums, foxes functionally erased from entire survey zones. But that is not the part that should scare you. The part that should scare you is what the pythons did to the water. The Everglades is the drinking water source for over 9 million people in South Florida. It functions as a living filtration system, a precise interdependent balance of plants, animals, and hydrology that has been maintained for thousands of years. When the animals disappear, the plant communities shift. When the plants shift, water flow changes. When water flow changes, the filtration breaks down. The pythons are not just eating animals. They are quietly dismantling the infrastructure that keeps South Florida's water clean. And the government knew this was coming. They had survey data by the early 2000s. They had population models. They had estimates placing the python count somewhere between 30,000 and 300,000. A range so wide it tells you how invisible these animals actually are. Still, the snakes kept winning. Every trap method, every detection technology, every incentive program, the pythons adapted around all of it. That is why Loki's headless body felt, to the USGS team, like the first genuinely good news in a decade. But here's what nobody's telling you. While the bobcats were learning how to kill adult pythons, something else was happening on the other side of the equation, inside the snakes, in their cells, in their genetics. And whatever the cats had figured out, the pythons were about to make obsolete. Genetic freak. To understand what is actually being fought in that swamp, you have to look at the python's biology directly, and it is genuinely unlike anything else in the vertebrate world. A Burmese python's jaw is not fused the way a mammalian jaw is. It is connected by flexible ligaments that allow the mouth to open to an extraordinary width, what biologists call gape size. A 10-foot python can swallow an adult white-tailed deer whole, not metaphorically, whole. The tissue stretches around the prey as the recurved teeth ratchet inward. That part is well documented. The part that gets less attention is what happens next. Within 48 hours of ingesting a large prey item, a python's heart increases in mass by roughly 40%. Its liver and kidneys expand dramatically. It produces digestive enzymes powerful enough to dissolve bone and cartilage within days. Then, the metabolism shuts back down to near zero, and the snake can go 6 months without eating again while barely deteriorating. It is the most efficient consumption machine vertebrate evolution has ever produced. And in the Everglades, it is getting better. The pythons in Florida are growing faster and reaching larger sizes than their counterparts in Southeast Asia. Some individuals have been documented at nearly 20 feet and over 200 pounds. Researchers initially attributed this to abundant food and favorable climate. Then they found something that changed the entire frame of the problem. Here's where it gets genuinely alarming. Burmese pythons in Florida are crossbreeding with Indian pythons, a closely related but genetically distinct species. The Indian python is native to regions with significantly colder winters. It has cold tolerance that the Burmese python does not, and the hybrids being produced in the Everglades are inheriting that tolerance. Cold weather has been the one natural barrier keeping this invasion contained to South Florida. Burmese pythons die in a hard freeze. That is the only reason they have not already spread into Georgia, Alabama, and the Carolinas. The northern limit of their range has always been Florida's brief winters. The hybrids may not have that limit anymore. Laboratory studies have already confirmed that some hybrid individuals survive temperatures that kill a standard Burmese python. If this genetic trait spreads through the population and there is no mechanism to stop it, the pythons will not stay in Florida, the marshes of Louisiana, the river bottoms of Georgia, the coastal plains of South Carolina and Alabama, ecosystems that have never seen a Burmese python, wildlife that has no behavioral response to them, states with no removal infrastructure, no trained hunters, no monitoring programs. And get this, the Judas snake program, the most effective human tracking method ever devised for this species, where male pythons are outfitted with transmitters and used to lead researchers to breeding aggregations, is showing signs of diminishing returns. The snakes are becoming more cautious around human scent near tagged animals. They are learning, not consciously, not the way a mammal learns, but through selection pressure. The individuals that happen to avoid human scent in high traffic areas survive longer, reproduce more, and pass those behavioral tendencies forward. The snakes are getting harder to find at exactly the moment finding them matters most. Which is why, right now, the only thing standing between Louisiana and Georgia and what happened to the Everglades is a handful of people working in the mud every night. And one of them, is more dangerous to these snakes than any government program ever devised. Ultimate hunter. If there is one human being the pythons of the Everglades should fear, it is Donna Khalil. She is a professional python hunter who has spent years developing a level of expertise that is essentially unmatched by any other individual working in this field. She does not use complex trap systems or remote sensors as her primary tools. She uses her hands, her eyes, and an understanding of the swamp built through thousands of hours of direct observation. Donna has removed over 1,000 pythons from the Everglades during her career. Here's how she does it. Her method involves driving a custom-built pickup truck outfitted with an elevated platform in the truck bed, giving her a line of sight over the tops of the sawgrass. She works almost exclusively at night, when the pythons are active and their body heat creates a faint shimmer visible through the dark. You can spend 10 hours on those roads and see nothing but flat grass and black water. And then, something about the pattern in the headlights looks wrong. A slight coiling shape where there should be none. A texture that does not match the vegetation, and the hunt is on. When she spots a snake, she has seconds. Burmese pythons are fast when alerted, and a 13-foot animal can disappear into waist-deep water faster than most people can run. Donna jumps from the truck platform and grabs the snake behind the head before it can orient toward her or submerge. She has been doing this long enough that the grab is reflexive, but it never becomes routine. What makes this worse is the teeth. Python teeth are recurved, like small fish hooks. When a python bites, the teeth angle backward into the flesh, which means pulling away tears the wound open wider. The correct response is to push into the bite, compressing the mouth to unhook the teeth. Donna has done this more times than she can count. She has scars across both forearms. She once wrestled a 19-foot animal she described as trying to hold a telephone pole that was made of muscle and actively trying to kill her. She never quit. Donna also teaches. She runs training sessions for new recruits entering Florida's python removal program, passing on the visual cues, the approach angles, and the handling techniques she has spent years refining. She is adamant on one point. This is not about hatred of the animal. The python is doing exactly what its biology is designed to do. The problem is that it is doing it in a place it was never meant to be. Removing it, to her, is an act of ecological repair, not vengeance. And here's the part the removal program doesn't put on its website. Every python Donna takes out of the swamp is required to be documented. Body measurements, weight, GPS location, health condition, reproductive status. That data feeds directly into the research models that USGS and other agencies use to track population movements, breeding patterns, and the effectiveness of removal efforts. Donna is not just a hunter, she is a walking data collection system. She and Sarah's team operate as a single, coordinated organism. Without that collaboration, the Everglades would already be past the point of recovery. But here's the thing, no one in that program talks about openly. Donna Khalil can remove 1,000 pythons a year, and the snakes can replace them faster than she can find them. The removal effort matters enormously, and it is still not enough on its own, which means the humans cannot win this alone. The ecosystem has to help, and what the cameras are now catching across dozens of sites suggests it already is. American alligators have been fighting pythons for years. The relationship is complicated. A large python can kill and consume a juvenile alligator. And in the early years of the invasion, gators were documented losing encounters with large pythons in multiple recorded cases. But large alligators have proven to be more than a match for the snakes. Trail camera footage from multiple sites has captured 10 and 11-foot gators seizing pythons by the midsection and executing the spinning death roll, the same killing technique they use on large prey, until the snake's spine fails. Gators in python-heavy areas appear to be actively targeting the snakes now, as if recognizing them as both competitors and a reliable food source. The birds are getting involved too. Great blue herons and red-shouldered hawks have been documented preying on juvenile pythons near hatching sites. A heron's beak is a precision instrument. It can drive downward into the skull of a hatchling python with enough force to kill instantly. And this part matters more than it sounds, because the most effective intervention point in the python life cycle is the hatchling stage, before the snake grows beyond the reach of avian predators. Every baby python a bird takes is one fewer adult, consuming hundreds of pounds of native mammals and laying another clutch of 50 to 100 eggs. bobcats striking the cervical spine, alligators executing death rolls, herons hunting hatchlings. The Everglades is assembling a defense no biologist sketched on a whiteboard. No human program could have designed this, but the pythons are adapting faster than any of it. And the monitoring data from the northern Everglades is what is keeping Sarah Carver up at night. Northern threat. Back at the USGS field station, the map Sarah pulls up every morning now shows something it did not show 2 years ago. The hybrid snakes, Burmese crossed with Indian, are appearing in increasing numbers in the northern regions of the Everglades. They are clustering in areas closer to the state line, moving through habitats a standard Burmese python would not typically venture into. Some unconfirmed reports have placed pythons as far north as the Georgia border. Researchers are cautious about attributing those sightings to a breeding population rather than escaped pets, but the pattern on the map is not one anyone wants to look at for long. Sarah's team is not waiting for certainty. Monitoring stations equipped with eDNA testing technology are now being deployed across northern Florida. Environmental day testing works by sampling water from streams and canals. When a python moves through water, it sheds microscopic traces of genetic material. Those traces can be detected in a water sample, even when the snake itself is completely invisible. It lets researchers confirm presence or absence in areas too difficult to survey on foot. Here's what that really means. For the first time, they can tell if the pythons have crossed a line before anyone has ever seen one cross it. It is an early warning system, and right now, it is the only thing standing between South Florida's disaster and the rest of the Southeast. The race is on. Every snake removed from the Everglades today is a potential founder colony prevented somewhere else tomorrow. The removal program is not just about saving the Florida ecosystem. It is about building a firewall before the hybrids cross into states that are completely unprepared. Louisiana has 8 million acres of coastal wetland. Alabama has river delta systems that stretch for hundreds of miles. South Carolina has barrier islands and tidal marshes that have never seen a python. If the hybrids establish themselves there, the Florida disaster repeats. But without the years of infrastructure, expertise, and public awareness that Florida had to build from scratch the first time, and the second-generation Everglades wildlife, the rabbits and raccoons and foxes whose parents survived the worst of it, is harder, warier, more aggressive toward the invaders than the generation before. But that wariness is a Florida trait. Animals in Georgia and Alabama don't have it. Their ecosystems never had the pressure to develop it. The bobcat that killed Loki is a symbol of something real, the capacity of a living system to respond, to adapt, to push back against what is killing it. The alligators patrolling for snakes, the herons killing hatchlings, the hunters like Donna working the roads until 3 in the morning. All of it matters. All of it is part of the same fight. But the window to contain this invasion is closing. The snakes are changing faster than the methods being used to catch them. The hybrid cold tolerance data is real, and the implications are clear. If the containment fails, the Everglades will not be where this story ends. It will be where it started. Right now, as this video plays, USGS biologists are somewhere in the sawgrass checking tracker signals that have not moved since last night. Professional hunters are on elevated platforms and pickup trucks, scanning the dark for a coil that does not belong in the headlights. An eDNA station in a creek north of Lake Okeechobee is quietly filtering a water sample that, in 12 hours, will tell someone whether the line has been crossed. Every one of those data points is being logged into the same tracking system that was watching Loki the night he went silent. The system that detects the absence of movement before anyone finds the body. The system that is now the only early warning the Southeast has. Whatever it finds next is the story. If this mattered to you, if the idea that a 25-pound cat is holding the line against a 13-foot snake while hybrids creep toward Georgia matters to you, share this with one person who still thinks this is just a Florida problem, and subscribe. The next field report is already coming in.